Okay, Math 3 Honors. Next part of this next section, 3.2.3, is figuring out how to take an exponential function and find its inverse. Now, I showed you how the x and y just flip-flopped in the earlier part of the lesson, but now I'm going to show you what it actually means. So, to do this, we need to figure out the inverse of the exponent. Now, if you think about it, you know, if you've got something like y equals 4 to the x, remember when we did inverses, we flip-flopped the x and y. So it'd be x equals 4 to the y. Well, now you have to resolve for y. And if you look at that, I mean, good luck. You don't know how to solve where y is an exponent. So we actually have to turn it into what we call a logarithm, okay? Because this is just going to be way too difficult. So a log is actually the exponent to which the base is raised to. So if you notice, when we have like y equals 4 to the x, we have a base to the exponent, equals the answer. Well, and I have that written right here for you. To take its inverse, it now becomes the word log, L-O-G. The base is now a subscript. The answer moves over after the log, and the exponent now turns into the answer. So log base of b is how you would read that, of an answer A, equals the power. So logarithms, if you look, are nothing but here's log, nothing but exponents. Okay? So if you look at this table, what I'm trying to show you here is, if we have the exponential form of 3 to the 4th equals 81, I can rewrite its inverse without having to solve it. And all I do is write the word log. Here's my base b right here. Okay. Here is my answer right here. And then my exponent, which was 4, is right here. Okay? Now, this is kind of almost circular a little bit. I'm going to erase that and re-show you how that works. We know that 3 to the 4th is 81. Rewrite it as its inverse, log 3 to the 4th is 81. See how it goes circular? Look at the next one. 6 to the 0 is 1. We know anything to the 0 is 1. Well, look, here we have log base 6 to the 0 equals 1. It goes in this circular format for logarithms. Okay, look at the last one. 2 to the x equals 20. So now look, 2 to the x equals 20. So just make sure your exponent is after the equal sign. Here's a few rules here. B cannot be 1. It's got to be greater than 0. Y's got to be greater than 0. Otherwise, the logarithm doesn't work. And if you ever see the word log like this, there's no base here. Well, you'll notice it really means log base 10 of x. It's written right here. And then if you see something like this, ln x, that's called the natural log. Okay, they show it right here. That one really has a log base e to the x. Notice how they did that right here. So if you ever see ln x, it's really log base e. If you see log x, it's log base 10. Otherwise, the base will be given to you. Okay? So look at a couple of things here. A logarithm is defined as the inverse of an exponential function. So if we have y equals b to the x, then log b of y equals x. Okay, and you'll notice, again, if you go circular, b to the x equals y, which is exactly what this was. Okay, there's a few restrictions off to the side with b being greater than 0 and not equal to 1. I already told you that, and that the y has to be greater than 0. Otherwise, you're going to be crashing into an asymptote. Okay, so if we look at a couple of these, look at this first one. 125 equals 5 to the third. The logarithmic function, log. What's the base? 5. What's the actual answer? 125. What's the power? 3. Reason, because 5 to the third is 125. And you can go backward. Okay, look at how this reads. 6 to the second is 36. I just read it. 6 to the second equals 36. See? Base, answer, exponent, and then answer. So before we get too far ahead in this, I want you guys to fill out this table. This is what I want you to do for today. And make sure you had yesterday's done. If you'd like to also fill out this basic exponent and logarithm key characteristics, I did it for you up above here, but there's nothing wrong with you guys doing it again here. And then I will very quickly show you tomorrow how to do these Richter scale problems because I have a shortcut. Of course, Carnegie tries to make it as hard as they can. I have a shortcut for you. And then here, you can do this part here. You can rewrite these as exponents. Let's see, do I want you to do this part here? It's rewriting it as the log, basically. If you want to try this part, you can. And try this part here, too. These are good practice problems, okay? That actually ends the whole thing. So, for tomorrow, at least get this table that was due for yesterday, and then try to do at least these two here. If you want to move on forward further, go ahead. I will be sending you answers, and don't forget, we have a Zoom session for third period, and that's Wednesday from 9:30 to 9:55. Second period's Thursday from 9 to 9:25, and it's just Q&A. I'm not teaching anything new. It's just questions, answers. Okay? See you then.